Lesson 99, linear approximation using differentials. Very similar to what I would think of as related rates problems. Related rates when we're talking about rates and, like a change in rate over time. So we use related rates, we take derivatives, all of that. Differentials, I feel like part of it is we're just dropping off the dt. We're not really necessarily saying in relation to dt in relation to time. It's just using the top part of that derivative. Now, a couple of things here. First of all, say y equals fx. Then if we do the derivative, well, one way to express the derivative of y, I know sometimes we say y prime, but we also, if we're taking the derivative of each side using differentials, derivative of y is 1 times dy. On the right there, what's the derivative of f of x? Well, the derivative of f of x is usually listed as f prime of x, and then times the derivative of the variable, and the variable is x. So dx. So this right here is kind of the idea behind what we're thinking today, using those differentials. When using differentials, the dx is represented by delta x. Change in x is what we usually say. I think of it, you'll sometimes see me, I don't know if I really do anymore, but when we do slope, you sometimes see slope written as delta y over delta x. So change in y over change in x, same thing. And as I mentioned, we use this concept. We're going to estimate change in another variable when given the change in one variable. Again, I feel like it's related rates all over. Okay, just a tweak on it. So let's look at example 1. Lena and Jen have a solid brass ball whose radius is 20 centimeters. They want to know the change in volume when a 200 centimeter coating is applied. Estimate this change using differentials. Okay, let's go back and gather information. Lena and Jen have a solid brass ball whose radius is 20 centimeters. They want to know the change in volume. What do we usually think of change in volume? Well, and in the past we've said dV dt, right? The change in volume over time. And when we're just talking, when they just say, differentials, the idea is we can say dV. Okay, so we're trying to find the change in volume. When a 200 centimeter coating is applied, what is that 200s?
Would that be dr?
What is it changing?
Yeah, change rate.
If you are putting a 200 thick centimeter coating on this solid brass ball, so it's adding 200 centimeter all around the outside of this ball. So does it make sense as changing your radius? Yeah. So again, in the past we might have said dr dt, but for the purposes of today, I'm going to say dr. And so that is the change in the radius. Okay. Estimate this change using differentials. What's the connecting formula I need?
Is it the volume of the sphere?
Volume of a sphere.
No.
4/3 pi r cubed. Okay. The 4 goes with 4 pi r squared, which is your surface area of the sphere. Okay. And these, I know some people don't call these basic, but this is a type formula that is kind of expected knowledge at this point. So I know we get them confused and forget them. I have to stop and think about them, but
I have to review this one.
yeah. So, but this is something that can come up and kind of expected knowledge. So, okay. So just like related rates, we're going to differentiate this using our differentials. So what's the derivative of volume? dV. Derivative of 4/3 pi r cubed.
4 pi r squared dr.
Okay, so multiply the 3 times 4/3 becomes 4 pi out front. Subtract a power, it's r squared, times the derivative of the variable, which is dr. We're being asked to find dV, so can you fill in your information? 4 times pi times r squared, so times 20 squared, times dr, so times 200ths. It does say to estimate, so that would be appropriate as a rounded calculator answer. What'd you guys end up with?
I got 100.
Okay. So if we go our minimum AP calculator or AP calculus, 3 decimal places. AP calculator, you know where I got that confusion.
Okay, just learning a calculator.
Okay.
Just becoming
The calculator that you now can't use next year at Purdue. So, okay, so 100.531 would be AP calculus or AP calculator, whatever you want to call it. What's my label here?
Change in volume, so units cubed per something, right? Or just units cubed.
Just units cubed.
Because we're not doing time. Yeah.
Right. And the units are
Centimeters.
centimeters. So centimeters cubed. As I said,
Yeah, that's pretty much what I think.
old news.
That feels very familiar.
exactly. Okay. Ready to talk about example 2 then? Example 2.
I just get bored.
I gave it away, didn't I? I always try and write them down ahead of time, but so often I forget, and I get to the end, I was like, oh, okay, I gotta write all this down for you guys. So I went ahead and wrote down skip 4. Okay. If X represents the number of units produced by a company in a given period, the profit P in dollars for the period is given by the equation P of X equals, yeah, you see it. Using differentials, estimate the change in profit when the production is increased from 115 units to 120 units. Okay. Well, let me remind you. Let me remind myself. What am I saying? It's not about you guys. It's about me. I need to remind myself. What does X represent? Number of units produced by this company in this given period. Okay. So X is the number of units produced. I need that for my brain. They give me a formula for profit. Let's see. We're being asked to estimate the change in profit. So what am I trying to find? DP. When the production is increased from 115 units to 120 units. Okay, so if we're going from 115 units to 120 units, and X represents the number of units produced, then going from 115 to 120 is your change in x, since x is number of units produced, so dx is 5. And I should point out that production was increased, yes? Would it be a slightly different scenario if it said decreased? Yeah, okay. So the fact is increased, it's a positive change of 5. Yes?
So, for me, just looking at this, since we have a function for profit and we have two numbers, couldn't we just plug both in and subtract?
Probably.
That
My brain is thinking like yours that makes sense.
feels easier.
Final minus the initial delta.
Yeah. But there's sometimes a calculus, and that's when it comes to like a multiple choice problem. Yeah, you can get away with that. When it comes to a free response problem, there's probably going to be more that you're going to need the calculus aspect of it. But in all honesty, what Virgin Market would probably say, the people who do the AP Calculus Lives, they're probably going to say they wouldn't give you something that basic then that you can do without the calculus necessarily. They're going to give you something more that requires the calculus. Okay, so, but valid question. Now, the one thing when we do this, estimate the change in profit when production is increased from 115 units to 120 units. Well, I guess we can talk about when we get to the end. But besides all of this, the other thing we're going to need to know is we're going to need an X value to plug in at the end. Thoughts on what we're going to use for X? What do we know about X?
We know derivative of x.
Yeah.
Represents the number of units.
It's the number of units produced. And specifically in terms of number of units produced, the production went from 115 to 120. So what would make sense for our X value to be?
Well, since we're going to be doing it when it's 120, it would be 120.
Actually, just the opposite. Our original is 115. It's being increased to 120, which is represented by the dx. And so we're going to use the 115, so the original value. Okay? Okay, P of x, let me write this down. 500x, whoops, try that again. 500x minus x squared minus the quantity 1/2 x squared minus 72x plus 3,000. Okay, so if that's P of x, we need to find dP. There's two different directions I could go with this. And I don't necessarily have a thought of which is better. Do you guys see the two different directions I was thinking? Do you see one direction?
Well, since it's just addition and subtraction, there's no multiplication. You can like combine like terms. You just have to distribute the negative sign to the second part.
Okay.
And then from there, you can get P of x equal to something cleaner, and then just do P prime of x.
Okay. So one option is, could we clean up like terms here? Yes. Do we have to? No. In all honesty, it's not that bad if you don't clean up like terms right now. Okay. Now, that's not always the case, right? Sometimes it is better to clean up like terms. In this case, because, as Roskam said, they're all just individual plain terms. It's not anything crazy fancy. Okay. So the other option is, if you don't want to clean up like terms, go ahead and jump into your derivative. Go ahead and differentiate. Okay. And as I look at my notes, I just have differentiated. Now, maybe that's what last year's class led me to do. Maybe that's why I just have the just differentiated here. Who knows? but either way.
Just go.
Huh?
So just go.
Just go right in? Okay, so, and I'm not going to write this as P prime of X. I'm going to call it DP. I mean, same idea. These are just all terms added and subtracted. Do keep in mind that subtraction sign is going to be distributed, as Ross mentioned, so I'm going to keep that in mind. Derivative of 500x, 500. Minus the derivative of x squared, minus 2x. Minus the derivative of 1/2 x squared, minus x. Minus the derivative of negative 72x, plus 72. Minus the derivative of 3,000, 0. Clean up now, or plug your information in. Okay. Oh, hold on. Hold on.
We are missing the dx.
Yeah. I was like, wait a minute. What just happened here? All of these terms were what type of terms? X terms. And in my brain, I knew I was going to do it at the end, but I should have mentioned it. So this is, when we did the derivative of 500x, it should have been 500 dx. When I did the derivative of x squared, it should have been 2x dx. Are you seeing what I'm saying here? This should have been x dx. This should have been 72 dx. What have we done in the past, though?
Just put it in the end.
Put a dx at the end. My apologies. That was a big oops. I was like, wait, where's my dx? Crud. Forgot about it. Now, here's the deal. I caught myself, right? I knew when I got to the end, I'm like, wait, why am I not using dx? Oh, wait, I never totally overlooked it. Oh, well. So, 500 minus 2 minus x is going to be minus 3x if you want, right? So, minus 3 times 115 plus 72 times dx is going to be times 5. Okay. Do the math, however. And what are we getting?
Yeah. 1,135.
Okay. 1,135. 1,135 what?
Dollars.
Okay. This is the change in profit. And so $1,135. Okay. It is a skip number 4. I don't have anything other than that. So whatever number 4 was, don't know off the top of my head. We can look at test, and you guys can have some work time. And we're just almost at halfway through. So.